Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Asma binti Abu Sama from University Kebangsaan Malaysia, and today I will be presenting a work by my final year project student Muhammad Nizamuddin bin Daud on a Zigbee-based energy saving control system for centralized air conditioning system. The background of the project was based on the observation on the air handling unit AHU energy consumption. What we have seen from a study by Saidur R on his paper Energy Policy 2009, the average consumption of energy per 100 square feet in university is on average 70 to 300 kilowatt higher than in residential areas. So we want to do something to reduce this energy consumption, but that's a problem. We have seen that for university, the air handling unit is complicated and it is not possible for us to directly touch the system itself. So we are going to try to solve the problem on the outer side of the AHU starting from the switch. Specifically in my faculty, the Faculty of Engineering and Built Environment, we have seen that the two departments that consume most energy are the civil engineering and second, the electrical, electronic and systems engineering. Okay, so the high consumption of energy mostly come from the usage of laboratories, but we cannot intervene. Okay, the intervention cannot come on the laboratories for education purposes. So the solutions are targeted towards lecture halls as well as offices, and the majority of offices are actually lecturers' offices. Okay, so when we want to reduce energy consumption in these two areas, we have look at the different solutions, okay, existing nowadays in the most recent years, okay, in the era of Internet of Things, IoT. So we have seen that most solution actually target smart buildings where the design can be incorporated, okay, from the start of the design of the buildings itself. But what about old buildings? Okay, those that exist in UKM, for example. So we have closed space, okay, closed space individual offices for the lecturers, and these lecturers actually shares the same air conditioning system, okay, a centralized air conditioning system. So how do we solve such problem and in such context? As a solution, we propose an intelligent control system to automate the switching on and off of the centralized air conditioning system by an automatic detection of human presence in the room. Okay, and the communication is done using Zigbee. There are a few solutions in the wireless sensor network, but we have chosen to work with Zigbee due to its advantages that suits our purposes as well as the context of our study. First of all, because Zigbee has a flexible network structure, and Zigbee is popular because it has a mesh structure instead of a star and so on. Okay, so this is very suitable in the sense that one node connection can be connected to others, okay, and not directly connected to the main Zigbee node. All right, so the second one is the fact that it has a very long battery life. Okay, so it is resources optimized. Third, because it has a low power consumption, and actually due to the low power consumption that we can have a long battery life. Okay, it is very easy to install and as well as implement it. Okay, it can support a large number of nodes, for example 6,500 nodes. Okay, it is a very low cost system. Okay, it is more reliable and self-healing, and again the setting of the network is very simple and easy. This slide gives an overview of our methodology. So we have two parts. First one is the control system And second one are the detection system in the lecturer's room. So in this control part, we have the Zigbee module, okay, as well as the microcontrollers, and they are actually attached to the switch of the air conditioning system, okay. And on top of that, we have a display to tell us, okay, whether there's a presence of lecturers in their offices or not, okay. So if there is no lecturer, the display will say zero presence, and then someone can switch the air conditioning off manually. Okay, again, we are doing this manually at this stage because of the fact that we cannot touch the AHU system. The only part that we can work on is the switch itself. Okay, but the problem is that we cannot switch off the air conditioning without knowing the presence of lecturers in their room. So this system will plant a detection sensor, which is the PIR sensor, okay, that can work with motion detection. Okay, and based on the detection, we will communicate the information through the Zigbee communication modules. So this is the logical flow of the system. For example, this one is from the detection part. Okay, we'll start by the reading of data from the PIR sensor. Okay, if there's a presence of movement, for example, yes, then we will record the status every 15 minutes. Okay, so this status is recorded and delivered to the coordinator or the controller. Okay, but if there's no presence, okay, after 15 minutes, we will go back in a loop, okay, to read data again from the PIR sensor and verify whether there's a presence of movement or not. So in any case, the status will be recorded and then it will be delivered to the coordinator to be recorded as historical data. On the coordinator side, basically we read the data coming from the detection system and we count the number of room which is used or without presence of any lecturer. And then there's the display unit, okay, to display how many rooms are used and not, okay. And then if the total number of presence is actually zero, we will propose in the display to please close the switch. So this is the result. First of all, I want to show you the hardware results. Okay, so in terms of connection, circuit connection, we have our PIR sensor, we have our Zigbee module, and of course we have our microcontroller. We have used Arduino Uno simply. Okay, so the hardware was implemented at the coordinator side near the AHU switch, as well as in two lecturers' room. Okay, so actually the total number of room that shares the same aircon unit are actually 12, but we only tested the system on two lecturers' room. So for this overall system, the total cost are actually 445 ringgit, and we will see how this cost will be compensated with the energy reduction that we can save. And this is actually the result of the RSSI, okay, of the Zigbee system, okay, versus the distance. So we have seen that the Zigbee can cover up to 11 meter actually, okay. So this is very sufficient for the wings that we're working with. And obviously there's the RSSI is the highest actually at this point 1 meter, and then it goes down until about 67 decibel. Okay, but this is still a good quality, and we have seen that in terms of reduction, the reduction is quite small. Okay, and this is very good for our context of study. So based on the implementation, we have seen that there's a few times where the room was empty actually. Okay, so here for example on Tuesday we have about 13 times where the room is empty actually, and when we are talking 13 times in the range of 15 minutes, because the system was recorded every 15 minutes, so there's a 13 times 50 minute time where the room was empty, and then we have less absence on Wednesday, but then again on Friday we also have some absence. So this result, arguably we say that 15 times 13 or 15 times 4 times actually not very long. For example, on Wednesday it's just 1 hour, but the thing is, this study has proven that there are times when the lecturers are not in their offices. Okay, and if we can control the aircon, switch it off when they are not present, then we can save some energy. So this actually shows the result, okay, from the system. The current system energy consumption, the actually yearly it goes up to 4,700 ringgit, okay, and only for 2 rooms, okay. But if we use our system yearly, we can save up to 680 ringgit and 40 cents, okay. If we compare with the cost of the system, which is 455 ringgit, and it's actually a one-off cost, so we can see that we can save, okay, some money as well as energy consumption, okay, in this case. So we have seen that this system have a big potential, okay. One argument, okay, that come from the implementation is the fact that we just considered 2 lecturers, right? If we consider, for example, 12 lecturers room, obviously the possibility of having 0 presence is lesser, okay, and in that case we will maybe saving less energy or electricity, but still the problem can work, okay, and we have seen that it's actually cost effective as well. And with that, we end our presentation today with a conclusion. We goes back to the problem where we want to control energy for a centralized air conditioning system, and in an old building actually. So the solution came in a Zigbee-based monitoring system, which can reduce resources, electricity as well as money. And the perspective from our study, the first one is actually we would like to do a battery efficiency test. We couldn't do it because the period of the test was actually only for 1 month, okay, and in the 1 month period the battery is still there. So we are supposed to prolong the test so we can know when will the battery die, okay, with the current consumption and so on. Second one, we would like to see the comparison, okay, using a different motion sensor. So we are not sure at this moment whether PIR is the best sensor or not. So we would like to do this comparative study. And finally, again, going back to our first objective, we would like to work directly with the AHU control system instead of just working with the switch to manually on and off it. Okay, so we would like to directly work with this control system. And that's all. I open for question and answer.